Hello folks, well today it's the final one from the current set of repairs from our mystery benefactor Alan. These are actually repairs to go back. There was the, let's guess, what was there? Was there the 77? No, there wasn't the 77805. This is a 77104D UK Baby Midland. It's not a porter pack. We did the Academy 502 for him, and we did the CRT Mini. So this is the third one. And final one. And then we've got some other customer repairs. We've got a 77805 UK porter pack, and we've got a Fidelity 1000. We've got a Uniden 200. Now, yesterday I did a Uniden 200 out of that batch we bought from Lancashire, which we'll be selling on eBay. So I haven't published that video yet, but it's strange that the very same day I did a Uniden 200 for me, we get a Uniden 200 in the post. See, we're fed up of seeing Uniden 200s, but the good news was that the one I fixed for me yesterday was repairable, because they can be now not repairable if they've been faffed with too much. And that's mainly because the synthesizer chip has long been obsolete. But I did have to put a meter in it, and luckily mystery benefactor Alan gave me a couple of meters about 9 months ago, and one of them was okay to use in that. Right, we'll plug this into power. So you can always tell when it's the D version because it boots up on channel 9. The non-D version, which is the better version, has 9 on the channel selector switch because it uses a normal multi-wave for channel selector switch, whereas this actually uses a rotary encoder. It's just up down but on a rotary knob. Oh, the signal generator's on something or other. So we'll put that on channel 20, and he says he's gone through it for dry joints, which I'm sure he has. Where did the mic go? Good Nottingham phrase. The floor is the dog shelf. Where did the mic go? The dog shelf. So it's an ordinary mic, not a speaker mic, and that's the correct mic which these would have come with. So I won't bother opening it up, and we'll just go through its parameters right now. And I printed up our previously done thing because of the different versions. I've gone to the trouble of doing those photos and that for alignment purposes. So can we get this done in 20 minutes? I'm taking the Nissan Leaf for some tyres. I don't know whether it wants 1 or 3, but we go to a tyre garage which is not one of those, which, you know, there's certain tyre garages where you've got 6 millimeters of tread all over the tyre, and they'll tell you want new tyres. We go to a tyre garage that tells us the truth. Right, transmit. I'm on the 3-watt scale. Let's switch picture in picture on. I'll have it on the left whilst I'm working like that. And it's doing beyond 3 watts. It's doing 3.1 watts. Let's change channel. Channel 40 is doing 3.1 watts. And channel 1 is doing 3 watts. Now that's unusual it's that way around, but it is. Low power, let's go back to channel 20. Low power is doing what? 210 milliwatts. Back to normal power, and just look at the current consumption. It's 1.014. for what it's worth, we'll look at deviation, but is the test set on behind me? No, it isn't. I'm going to switch the test set on behind me, so that it's had at least a 10-minute warm-up before we ask it to do any sums. Ugh. Wallow. We've got nothing. Wallow. Wallow. Well, according to this, wallow. 1.5. It might be lying. We're unlikely to be doing the VCO. The frequency we'll take with a pinch of salt because the test set's only been on 10 minutes. 27,79092. It's not actually off frequency, but it will bring it up to 125. It's well within, really. So, with that in mind, we'll set the signal generator to the same 2779. Oh. So we've got that matching the same as what the set's on, so that we're not giving it a false reading. I still have my test speaker attenuated, and we will get that back to normal. Let's get a SINAD reading now, so we'll go over to the SINAD meter. Oh, well, it's not that good actually, which is probably why it's here. I don't normally expect much better than 1 microvolt, but this is doing 1.15. The 10 dB is doing 1, and for 20 dB, which it is doing 2.4. Let's look where the squelch is. So on full squelch, it's 300 microvolts, which isn't that far out. And threshold is 1 microvolt. Meanwhile, we'll put S9 equivalent signal onto the test set, and we get 1 bar. So S9 is at the moment 290 microvolts. So that's pretty well out. It's not applicable. They're working, they're working, they're working. That's not applicable. Mic's working, speaker's working. Oh, we're getting down this, aren't we? Let's go over to the main meter, and we're looking at, have we got picture in picture on? We have, yeah. So key up, it's supposed to be 4 bars on for 4 watts, and it's supposed to be 1 bar for low power. It's no bars. So I'll just put low because it's hard to determine when the set's not even doing 4 watts. So get this opened up. I never took the screws out, did I? Oh, I must have done. Doesn't matter anyway. Oh yeah, losing the plot. May be able to just put the speaker to one side on this occasion. I'm going to look at the bottom side afterwards. I'll tell you what, we'll take the bottom off now. Don't know whether, I know Alan has said in one of his notes that he was formerly, or still is, involved in computer servicing to component level. So he probably does isopropyl alcohol, perhaps he doesn't, we'll find out. But I will do if he hasn't. I mean, this model isn't that susceptible to dry joints. It's I'll go over that anyway. I mean, it looks pretty clean, but we'll go over to the courtesy at the end. While I disappear from my tyres, that can be drying. Right, we'll start with transmit, like we usually do. Especially if you can find the right tools. That'll do nicely. So looking at capacitors, I can't see anything dodgy. So we've got our photo, so we're going to go transmit, transmit, transmit. That's not supposed to have a core in it, and that's done with the spectrum analyzer. That's transmit power, so we need to turn that to full right away as part of the tune-up procedure. When we find something that fits. It's doing 4.5 like that. Now I've put it that high, I need to be pretty quick so I don't overheat the transmitter. Legality aside, that's not there to make the set do 4.5 watts. It's there to enable us to do a tune. That's centered. That was well out. That's centered. That's brought it to 5 watts. Now we'll pop it down to 4. Remember, this is a commercial test set, so when I say it's 4 watts on this test set, it could well be 7 watts on a hobby meter. So this is what the government would go by if there was an inspection. It's actually a little bit high. So we've got, that's still a little bit high. I'll tell you what, it seems to be where it wants to be. So it's 4.05 on channel 20. On channel 40 it's 4.05, and on channel 1 it's 4. And that's the way around you'd expect it to be, because it's more difficult to achieve the higher frequencies than the lower ones. So chances are we may have less current consumption now it's being tuned. So let's have a look at the ammeter. 1.23, call me a liar. Gained an extra watt for an extra less than 200 milliamps. So let's see where low power now is. Still 210 milliwatts. Is it adjustable on this? No. We'll come back to deviation. Let's look at where the meter now is on the front. So on transmit, on full power, we get 4. On low power, we're still getting nothing. So I need to adjust that so I get 1 bar on low power. There you go, and then it'll still be 4 when we go back to the full set. So that's now correct. Now when we put this on an aerial, it may be totally different, but into a dummy load is how it's set. So that's now 4, so that's corrected. So we won't do frequency. I'll tell you what, we will do frequency and we'll come back to it. I'll come back to it later on, after my tyre's done. Right, so we'll look at the frequency counter and bring that up if possible. There we are, it's 5 toggling 6. So now we'll reset the signal generator so that it's on proper frequency and not radio, what the radio was on. I really want to get some improvement on this because the receive is the letdown now. The first thing we're going to do is the detector. Miles out. Right, good. We'll go to the SINAD meter now. Not that we've got anything better, I'll just tell you what the SINAD now is. It's 1.5. It's actually worse. And that often happens when you do the detector. So we've now got to make it better, haven't we? So we'll go over to the SINAD meter on the inset picture. Turn the attenuator down. With no improvement on that one. No improvement on that one. No improvement on that one. And no improvement on that one. Well folks, unless we've got the detector in the wrong position, chances are we've got a duff filter. It won't be duff transistors in the front end. These things get plonked, the filters get broken, and both the filters can affect the sensitivity. I'm going to just recheck this detector. Just in case there's a false point. Go back to the oscilloscope. No, that's not the oscilloscope. That's the oscilloscope. That tool's not fitting as well as I'd like it to. What we've got in trimming tool stash. Had 2 tyres. I'll be now skint for the next 6 months. Right, so we took out the filter, which is an HT, put in a filter from a scrap chassis. That's how we bought it, a Midland 095. Certainly seen a lot better days. I mean, the original fault on that would have been dry joint, but clearly the person who decided to scrap that couldn't find the fault. So, we've now got the sensitivity. I've just powered it up, and one of the clues that it's going to be the 455 filter rather than the 10.695 is how much we had to move the detector coil to get the detector to be correct. So I'm now going to redo the detector, which will probably make it all wacky again, but that's the filter that's come out, so we'll throw that one away. So actually we'll go to the oscilloscope. Wrong channel. Now why is that shifted? Have the mice been adjusting the oscilloscope? So 100 microvolts, let's see. Still where it was. So now we've got 1 microvolt, and we've now got an acceptable SINAD reading. So we'll go over to the SINAD meter. So I like it to be under 1 on these. They're not the most sensitive sets in the world, but it doesn't really affect them. It's 0.68, I mean, absolutely fine. For 10 dB, 0.55, and for 20, it's 2.3, so that's not really changed. So I'm just going to do a final check that that is the best we're going to get with the other coils. Back to 12 dB, 0.6, I have improved it, it's 0.61 now, and for 12 dB, for 10 dB it's 0.52. I'm not bothered about the 20, that can stay put. So with 100 microvolts on the signal generator, we want the meter to read S9. So with my crib sheet, it is got it. This one down here. Oh, that's interesting. We have nothing. So I'll put a whacking great signal on until such time as we do have a signal. Oh, that's better. right though. We'll come back to that because that isn't where it should be. I think we've probably got a duff capacitor or something which is causing it to be insensitive, because we know that it's working fine on transmit. Let's go into transmit, press transmit, or they all light up. Don't think I've ever had that before. So we'll come back to that. I'll do the deviation while I'm here. I've just been up to the pig farm up the road, taking some footage on the camcorder we used for the on the air test, and also used the 1990s RUVI, Sony RUVI camera, because I like vintage cameras. In the pouring rain. Trust me to choose it when I went to the post, and I thought, oh, I'll take some baby pigs because they've had babies over Christmas. Nobody's eaten them yet. Alright, let's look at deviation on the test set behind me. Wow, it's a bit low. And deviation is there. I don't think that's been altered ever. Wallow. Okay. So that now reads where we want it to be. That's 2.2 average to a 2.5 peak. So put it back on the Marconi test set and see what we've got on the Marconi test set. And we can find out whether the test set's lying today or not. What are we on? Wrong mode. Wow, it's exactly right. So it was, when I said it was 1.5, it was. The test set spot on. So I'm going to look at the circuit diagram, because apart from that we're done. I'd like to get a, it's not the end of the world if it reads a bit slow, but it'd be nice if I could just bring that up. And while I do that, I'll come back in 20 minutes so that we can use the isopropyl alcohol and clean the board. I'll just turn the power supply off. I'll just go over that. So once again it was the 455 filter causing the sensitivity problem. So we're just at the top of the road. I'm on the Sony camcorder we usually do for the on-the-air tests. Model number I'll notice, and I'm going to do this initial sequence where these pigs are. Seem to have had some babies over the period of Christmas, and let's see if we can just zoom in on some of those. And if I look over there, I can see ones that have escaped from the electric fence, so they're between the two fences like naughty little piglets. What I want to do in the pouring rain is go over to the RUVI camera from 1990s. Now on the RUVI camera, which uses high 8 tape in a cartridge, looking at the same sequence, If it not been raining, I should have brought half a dozen different camcorders up here. More fun would have been black and white reel to reel. So we'll just finish off. I don't know whether that's in focus with the rain. Back on the Sony whatever camcorder, which I'll say in the blurb. Oh, we've got some little piglets there. This doesn't look in focus, and I don't know what to do about it because it's pouring with rain. So we'll go back to whatever I've inserted this bit of footage into. Right, so back into this. Let's pop that picture off. I've blown up what this is out of the instruction book for the right version. So we've got the Texas Instruments, is it TL489 bargraph driver chip here, and you've got the 4 LEDs. So from this side you can see we've got a 10 microfarad electrolytic capacitor smoothing pin 7, which is going to be, no, I'm telling you lies. That's smoothing the pin 7, that's fine. Forget that. We've got here, we've got the input coming from the transmitter. So the sensor and all that comes out here. We've got the preset we've adjusted for the correct number of bars. You've got 2.2 microfarad capacitor there, which can't be faulty, otherwise we wouldn't be able to set this up properly. Then we've got the preset, which comes from the receiver. So through that diode, da-de-da-de-da, what we have got is that capacitor. If that capacitor was leaky, it would drag down this voltage. So really that's the only thing which we can look at. It appears to be capacitor 138, looking at that. So if you see we can find 138, so it's going to be somewhere between the receiver and the bargraph driver. 139, 141. So I've got to go and look at the layout. What value did it say? 1 at 50 volts. That's 2.2. Now I'm going to have to look at the layout. Okay, so it looks like it's here. 136 I think it is. I can't quite see the number. If that turns out to be 1 microfarad, then we've cracked it. So it's that one there. Yeah, that's 1 microfarad. Negative to the right. So see if that works any different. Of course it starts up on channel 9. No, no different whatsoever. Has it got the wrong preset in it? RB102 should be 50k. Try and read it in circuit. £48.5k. So that's not wrong. I'm going to change that 2.21, even though the transmit is fine, because if this was faulty, because it gets quite a hefty amount of signal when it's in transmit, and notice I did have to change the position, didn't I, of the preset, because it was reading under, so I may have compensated for a faulty part. I'm trying to find this on this side, so it looks to me there. It is. Right, see whether that's changed anything. Back to channel 20. No, it's exactly the same. Check transmit. 4, low power 1. Okay, so I've ended up changing the filter again. This one off a Cybernet set, so that's another Duff filter, which worked better than the previous filter but wasn't right. We've got a problem with the squelch. So we'll try that test again with the squelch. Set threshold. got the preset too high here, and it's this one down at the bottom. Nope. 270, 300, no change despite careful adjustment. Okay, I've decided to change the 10.695 filter as well, and we seem to have got some more meaningful squelch action. You just don't know when these have been dropped in the past and these filters are broken. So what we're going to do, what meter are we on? Let's just look at the SINAD meter again, and I'm going to retune. I've just done the first coil and it was making quite a difference. I thought we'll just do the second coil. We'll just back the signal generator off. And turn the attenuator down. Let's see where the... Aha! Oh look. Wow. 100 microvolts, full set of bars. We can now turn that down a bit. There we go. So a slight increase in the signal. Excellent. So hopefully we've got proper squelch action now. I'll go to this extension speaker on the wall so you can actually hear it. So signal generator's off, set the squelch. Signal generator back on. Let's put the attenuator on, then you can see what's happening. So red light tells us the signal generator is in standby. It's parked at 0.3 of a microvolt. It popped in for a second as we switched the signal generator on. Absolutely normal squelch action. Good, we're done. So that was a new ceramic filter because I don't have any used ones. They seem to suffer. So we got to the bottom of it. So the two capacitors were unnecessary. But part of the diagnosis. So it's 455 filter, second hand, 10.695 filter, new, forgotten what I put in now. One microfarad and 2.2. 0.8. Better check the tight squelch now. 100. So that hasn't altered. Now, we had reasonable squelch action before, but if you remember, the detector was miles out, and I think the detector's been adjusted to make the squelch satisfactory. But anyway, it wouldn't have sounded right like that, and it was as deaf as a post. So that's a real satisfactory conclusion. So really, just a couple of filters on that. So we'll get it put back together. And that's the third and final one. Of the repairs for Alan. Right, I'll get the speaker back on. I thought this was going to be a 20-minute tune-up. But apart from that CRT, I think none of them were that easy, were they? So will this be the last video for 2023, or will we be able to cram another one in tomorrow? Will it be the Fidelity 1000 next? Well, I'm not going to do the Uniden 200 because it only arrived yesterday, and I said we did our one. Don't know when that's going to get published. We've got the customer's Midland 77805. I'm tempted to probably do the Fidelity 1000 next. Yes, that'd be a really good set to try and get done on the last day. Right, we'll turn the signal generator off. So the second filter I tried was fine, which I'd recovered off a scrap chassis. The original filter that's come out of this set is no good, and the filter which I've just changed is also no good. So I'll make sure they go in the bin. You know, we have a lot of filter problems with these smaller Midlands. Right, let's go to the aerial, see if we can hear anybody on. Don't think that's going to plug in, do you? Why have I got that there? One niner Roger. I think we've got the Daleks on 22. Well, that's all right. A couple of conversations taking place for a change. Thanks for watching. Hope you enjoyed seeing all the things going into a Midland 77104 D UK from about 1987.